Awesome. Thank you so much. How is everybody doing? Good? Good. Yeah. Amazing to still see so many people at the second day. Yeah. As you can see, this is my talk for today. Now, if you have been maybe listening to my previous talks before, you might know that I have given similar talks before. This talk is like kind of a redoing of a talk that I gave several times last year. Now, this is my first talk for today, which has a bit of a, first a theoretical part and then a hands-on demo, and later on I'm going to give another talk that's focused more on the cultural aspect of cloud-native security and integrating it into your existing workflows. So a bit more about myself. This is me with my puppy, a 30-kilogram heavy Labrador who likes to be carried around because she's lazy. Yeah. So who am I besides a dog owner? Well, I've worked in the cloud-native space for nearly 3 years now. I identify as site reliability engineer. I've worked in the field before, but it's not my day-to-day right now. I'm also think of myself as a tech writer, technical writing, documentation writing. I work in the open source space. So actually, before I joined this cloud-native space, I worked for 3 years in the blockchain, cryptocurrency industry with open source projects. Yeah, so I like to work in the open source space. Also, I'm the open source developer advocate at Acquire Security. So I'm only working with open source tools. All of the tools I'm talking about in this talk, and all of them that I'm sharing are open source tools. And yeah, I'm a developer advocate. Here are some of the companies I worked with for. And I'm also an ambassador for Grafana, as well as Open UK. Open UK is an organization that promotes the conversation around policies related to open source, open hardware, open data. It's a pretty cool organization that does lots of different initiatives, but in the UK. So if you're ever in the UK, check it out. Now, to my talk. About a year ago, I got started climbing, and here's my first attempt of being a monkey on the wall. So I started climbing. What does that have to do with cloud-native technologies? Well, when you get started with anything new, whether that's a new hobby or it's a specific area, for example, security, it's a bit like climbing in that case, as an example. So when you get started climbing, for example, you wouldn't start climbing on a big stone wall, let's say, like in this case, right? You wouldn't do the extreme climbing right away, right? In an uncontrolled, likely pretty dangerous environment. It requires lots of experience. But instead, you would start in that kind of setting where nothing really can go wrong, where everything is kind of contained, protected. If you fall on a soft mat. Nothing can really go wrong in a major way. That's where you would get started, and then you would advance from there. Now, this is similar to when you get started with Kubernetes. Who here is using Kubernetes on a day-to-day basis? Cool. I spoke at conferences before where the hands wouldn't go up, so it's good to know. Yeah, so how did you get started with Kubernetes? Just think about the first time you spin up a Kubernetes cluster. It was likely not a large-scale production environment, but you would start with a local cluster on your computer first and then advance from there and expand the usage of the technologies. Similar to when you get started with, for example, Kubernetes operators. You wouldn't go ahead and install, an entire stack. For example, the Prometheus stack first. You would get started first reading about operators and then trying something more simple as first, I guess. Now, to cloud-native security, there are lots of security issues in the cloud-native space related to Kubernetes infrastructure, Kubernetes environments. Now, you will read these kind of headlines a lot that, for example, over 900,000 Kubernetes instances found exposed online, and this also includes people getting started with Kubernetes and then not knowing how to configure their own small-scale environments, and then exposing their resources in an unintentional way. So this is the bad news, that you will find lots of misconfigurations in particular, like not talking necessarily about vulnerabilities in your deployment artifacts, but talking about, for example, misconfiguration issues. And then things like these happen, where this is actually taken, this table, or like the snippet of like a large table, is taken from a database on GitHub from 2021, and it basically lists all of the different cloud misconfigurations that have been found within the year. And you will read this and you might think there are lots of misconfiguration issues that could have been prevented, or like things that you will probably never do. For example, there are lots of unsecure S3 buckets and other AWS resources listed in this table, in this database. And the kind of records that it exposed. Now, you will also find other security issues that could have easily been prevented. For example, what was it? No password protection or any kind of security protection protecting the database, and that exposed over 440 million records. Now, it doesn't go, I think, into more detail on what kind of records, but these are things that could be prevented by everybody, whether you're a security expert or not, on a day-to-day basis. Now, this is the bad news, that you will find lots of different information on misconfiguration, people accidentally misconfiguring their resources, exposing their private tokens, things like that. But the good news is that people are the problem. And I think that people can change, and that we can adopt more security-focused mindset in our day-to-day workflows. So the premise of this talk is really, and most of my talks, that security can be incorporated into all of the business functions. I don't consider myself as a security expert. I'm somebody who got started in the cloud-native ecosystem, working with the technologies, and then found myself in working with security-related tooling. And based on that, I think it's easy, especially before I got started with security tooling, I thought that it's something reserved for people who know their stuff in the space. But it actually can help even people who get started in their day-to-day to find, for example, those misconfigurations in their own private environments. Now, here is some information from a case study from Wise Engineering. Somebody who's working at Wise? Company? No? Cool. So they have, just checking, they have a really good engineering blog where they share kind of their learnings, their processes, how they integrate, for example, new tooling. So they shared this blog series on how they redid their entire open source based, I think it's largely open source based, security stack to get better insight into the security posture of their services, of their applications. And here are some of the things that they did and that they wanted to achieve by redoing their stack and implementing open source tools such as Trivy and open source security scan, and I will talk a little bit more later on in this talk. Now, something they wanted to achieve by redoing their stack was they wanted to assign ownership of vulnerabilities, of security issues. So when security issues are identified, they want to be able to give those security issues to specific owners to ensure that somebody's there to take care of that security issue. And that's not just within the security team, but basically anybody within their engineering team would get their issues assigned depending on which resources that they are responsible for. So that was something that was really important for them to achieve that. Then to get a global view of the state of the services, of the security posture of their services. So instead of just digging into, for example, the specific container image or the specific Kubernetes deployments, also to be able to see how is actually my entire system evolving over time, changing over time. How are our efforts regarding security and implementing best practices paying off in the long term? So that was something else they wanted to achieve. And then develop dashboards for different users and different requirements. We are all working with different resources on a day-to-day basis. Within your engineering team, you will have people focusing on different deployment configurations, different areas. So it's important that you can make the security scans, the security-related information meaningful to the person who's looking at it, because otherwise they will look at it a few times, or because it's a requirement, and then they will stop looking at it in the long term, and it will just be another tool that has to be maintained that's staying around. And then they wanted to remove difficult-to-use UIs. There are different UIs that kind of require some onboarding to get used to how to navigate it. And usually when you implement a new tool and you add a new tool to your existing stack, people have to be onboarded to that, but also it's then yet another process, another workflow that you're adding to your existing workflow. So they wanted to eliminate these decoupled processes. Now, Regarding my premise that you can integrate security into all other business functions, I will talk later a bit more of how SRE as well as cloud-native security go really hand in hand in terms of the goals that they have, what they are trying to achieve with different processes and with their tooling. So I will talk about that a bit more later, but basically to summarize, when we're talking, for example, in the SRE world about how we want to scale our services, our microservice applications, we also have to talk about how do they stay secure over time. So these are things that really are multifaceted, I guess, considerations. Now, next, when we get started with cloud-native security tooling, we need to find a security scanner, for example, or different security tooling. And security tooling will differ in different way, in multiple different ways. So when you get started with cloud-native security, you will likely be bombarded with lots of different tools. For example, lots of different vulnerability scanners that can identify vulnerabilities in your container images. So you want to understand how do they differ. When would you use one security scanner, for example, or one security tool over another? The first thing is the installation, the way that you install a tool and use it. Several tools come as a CLI tool that you install in your terminal or in your CI/CD pipeline. Other tools you would use through the UI, for example. Docker provides a security scanner that you can access, I think, just through their UI, through Docker Desktop. And for example, Trivy, that I will talk more later about and also give a little demo, comes primarily a CLI tool, but you can also then install it in your CI/CD pipeline, and there's a Kubernetes operator that allows you to install it in your cluster to scan running resources. Then the next thing is scan coverage. Of what does this tool scan? What can it scan? Now, scan coverage is different to code coverage. You can't really assess the percentage of resources that are scanned. But ultimately, when you implement, for example, security scanning or other security tooling, you want to increase the number of resources that you're able to scan to assess. And then the resource types that are used, generally, for example, a security scanner and other security tooling, they will need lots of permissions, lots of access to your resources, for example, within your cluster, to perform those scans. And for example, some security scanners, they will install additional resources in your cluster, in your environments, to be able to perform those scans to get that access. So you want to be aware of what is that tool actually doing in your environments. And then integrations can make it easier for you to remove or not implement decoupled processes in the first place. So more mature security tooling and other tooling, like you might be aware of, has more integrations available that you can make use of. So for example, engineers can use security scanning right where they develop their code itself, instead of having to use a completely separate tool. And then the last thing is the focus. Different tooling will be focused on different user groups. Is the tooling focused on security expert, on cluster admins, on engineers? Who's actually the target audience for their tool? And depending on that, tools will differ as well. Generally, you want to implement, for example, security scanning across your software supply chain, so wherever you use resources, and that's something you want to get started with right from the beginning, or can get started with right from the beginning. When you first select, for example, the packages, the libraries you want to use, you can scan those for security issues, and then all the way from developing your application to the version control using the registries you're using for your charts, for your container images, to infrastructure and code as code. Configurations. So there's really no matter how big your project is, you can implement security scanning along each step. Because ultimately what we cannot see, we cannot scan. And our goal is that we want to implement security scanning as early as possible. Because the longer we wait, the more complex the resources and the impact that those resources can have on the security posture of our application will be. Now, security scanning, I primarily use security scanning because I work at Accra, and our main tool, one of our main tools is Trivy. Who has heard of Trivy? Cool. Okay, most people here. Cool, awesome. Who here uses Trivy? It's a different. Oh, okay, so you've heard of Trivy, but okay, interesting. Few people use Trivy. Yeah, Trivy is just one one component of your software supply chain security. So Trivy primarily helps you to scan artifacts, for example, packages, container images, configuration files. Now, it can also help you, and there are other tools that help you to create metadata of your artifacts. So for example, SBOMs, vulnerability reports is part of the metadata. Now you can also like clarify metadata as like additional information that you need to run your application. But generally, there are different tools, for example, to generate SBOMs or to manage vulnerability reports. And that's something that also plays into the security posture of or like your entire security stack. The next thing is attestation, which is also another section, I guess, within cloud native security that you want to be able to verify who created an artifact or who's managing, who's the source of that artifact, and basically verify that the person who's claiming to be the owner is actually the owner. So you want to be able to make statements of that other people can verify as well of different resources. And then policies is something else that allows you, for example, in your cluster, you can define policies for tools such as Kyverno on how, like, who's allowed to do what within your cluster in case, for example, previous configuration fail up to that point. Or in case you want to enforce custom rules from within from your company, by your company. Now, I mentioned I'm talking a lot about Trivy. You can use lots of other security scanners. Here's like an overview of the different scanners, of some of the scanners that we have in the space. Now, they focus on different areas of scanning. You can have vulnerability scanners. So if you just want to, for example, perform vulnerability scans, for your container images, you might want to use a tool that's really focused on vulnerability scanning. If you're just using, let's say, Docker Hub and Docker Desktop, you manage your container images, maybe then their scanner is enough for you, and that's what you want to use. There are lots of different scanners available, and again, depending on your use case, you will want to choose one or the other. Now, Trivy is a completely open source project. Side note, we are aiming to reach 20,000 stars on GitHub, and we are getting close. So if you like Trivy, then please give us a star on GitHub. It would mean a lot. But here are like some of the different things that Trivy does. So Trivy is divided into 4 different types of scanners: a vulnerability scanner, misconfiguration, exposed secret, and license scanner. So you can perform either all of the scans at once or scans independently, and you can scan these different resources. Many of the scanners that you see in this graphic work similar way. Now, some of them, again, are focused on one type of scan versus the other. For example, Kubescape is within the CNCF and also performs different types of scanning. And now I have a little demo prepared to show you like how you can get started with security scanning really across all of your resources that you might be using. Where is it? Oh, it's there. Ah! How can I see it? Ah, okay. Oh, okay. Cool. Cool. Okay, this is a live demo. I've just prepared the commands, so I don't have to sit here and type, right, or stand here and type. Okay, so we want to integrate security scanning across all of our resources right from the beginning. So you have looked into different security scanners, and you've decided Trivy is the tool that you want to use, that you want to try out. This is how you can get started and with Trivy to scan your different resources. First of all, you want to make sure you have the right version installed. I'm pointing out specifically because within our open source projects, we have like nearly more or less monthly releases with changes to the tool. So you want to make sure that you're on the latest version. Then we want to go ahead and check out somebody else's repository, for example, and see how is that configured. So we can perform a repository scan of that remote repository next that details what's going on within that repository. Do we actually want to use it? For example, I'm right now learning Go, and I looked at different example projects. And before I actually installed them and started using them, I checked out like what's going on inside them. Are there anything that I might want to change? And I will get to that in a second on how that turned out. So if you perform a GitHub repository scan, you are provided with these kind of information. Can you all see that? Should I make it bigger? I think I should make it bigger. But then the table looks ugly. Let me first detail. Okay, see, like in this repository, it's not a very good one. It's a Node application, and you can find, which is another issue, but yeah, you can find basically here's the scan. And you're provided with these different information. First of all, you're provided with all of the vulnerabilities that are found in the package log file. Now, within Node application, you would actually need to install the packages to then be able to scan them. So you have here the different vulnerabilities, the severity of the vulnerability. Now, this classification, this information comes from different security advisories. So depending on the different projects, we will pull information from different advisories and then compare basically what you have present in your project to the vulnerabilities that we are aware of from those external advisories. And then you can see like your installed version, and then the version that's providing a fix, if there's a fix available. So these are generally the information you're provided with, and just the total number of different issues that might be there. So let's check out the next thing. We can also scan specific branches, which is really useful if you, for example, doing code review, somebody's PR, and you want to check out what kind of, like, if the new libraries they're using adds any additional security issues to your project before you then approve it, for example. So you're provided with pretty much the same information. I'm just showing you how you can like filter basically different resources. Oh, where am I? So you can also like perform a scan of a specific tag or a specific release. Where are we? Here. And I don't have this repository right now locally. Now, I can also scan, for example, just for vulnerabilities versus misconfigurations in that repository. Something else I can do. And then I can, well, I'm already cloned this repository just because I wasn't sure how good the internet is. I can get a repository locally, and then also like within, for example, my development environment, I can check the file system that I'm working with, if there are any issues that I should be fixing right there. So it's basically from deciding which libraries, which repositories you want to use, to then doing the local development, checking out what security issues are present in your local environment as you develop the project. Then you might want to go ahead and you want to package that application. And for that, you will need a base image. So for example, if I decide I want to use a Node base image for my Docker file, I can go ahead and scan that first for security issues before actually using that. Now in this case, I already know that this specific container image has over 700 different vulnerabilities. Now I don't expect you to go through 700 different vulnerabilities and assess them one by one. Nobody's probably going to do it, I hope. But what you can do next is apply specific filtering on your scan as well. So you, for example, only provided with the security issues that you can already take actions upon. So this is just something you want to be aware of, that a lot of times people will, maybe like I've seen like screenshots on Twitter of fancy UIs where people have been presented with several hundred different vulnerabilities and they get overwhelmed. Like people get overwhelmed by security scans usually. Like they express it as security fatigue, vulnerability fatigue, that they don't really know what to do with that information, right? Like most of the cases, like unless I look into these different vulnerabilities, I wouldn't know what they mean, right? And how it applies maybe to my project. So I'm not, as I mentioned, I'm not a security expert. I'm not going to sit there and go through it one by one. What I'm going to do is, instead, I'm going to filter the different issues that I basically can take some form of action on. Like if I already have to spend time on, I might as well spend time on the things that I have control over, that I can change. So where is the scan? So as you can see, there's still lots of different vulnerabilities. But instead of 700 something, we have just 32. That is a lot easier to assess. And then I could also filter, for example, by the severity of those security issues next. So I can, for example, say, okay, I only want to be presented with the high and critical issues, and then I can also put both of them together, that I only want to see the high and critical issues and the ones that I can already fix. And in that case, they're in this, before there was nothing in this container image when I performed that scan. But yeah, now there are apparently still some. So I could take actions upon these vulnerabilities that are presented to me now. Now next, I have my container image. Now I could scan the container image that I've built, but if I already scanned the file system, I can scan the different artifacts that went into this container image, and I scanned the base image, then I can go ahead and set up the configuration on how I want to deploy that image, how I want to use it in for example, my Kubernetes environment, and I can perform a scan of my different Configuration files. Now here is a repository with different configuration files related to my Docker file, my Kubernetes manifest, also my Terraform. Now I have here also additional policies, but that's for a different demo, so you can apply custom policies either through Rego, or you can also specify in Trivy different like edge cases on what kind of situations you want to have, for example, some vulnerability not shown or another vulnerability shown, so you could apply that here as well. But basically, then you can go ahead and you can scan all of the resources within your configuration file, and you present it with like the list of misconfigurations that are present there. Now, you can perform individual scans of, for example, your Docker file. I'm just going to rush through it because I want to show you something more interesting. So here you can scan your Kubernetes YAML manifest. And again, like these are misconfigurations that some of them you might ignore. What I found when I got started with Kubernetes a few years ago, I came across a project that doesn't exist anymore called Day3, and Day3 allowed you to also perform misconfiguration scans. And at the beginning, when I got started with Kubernetes, it really helped me to understand how I can better configure my YAML manifest. So if you have engineers within your team who are getting started with Kubernetes, to better understand what's going on within a standard manifest, even like a deployment, and why different fields exist, it's really useful to use a misconfiguration scanner in that case. Now, similar to applying different filters on your vulnerability scans, on your container image scans, you can also apply those filters on your misconfiguration scans. So you could go ahead and do that. Now, I don't want to spend the last minutes on this demo, because this is really just to show you how you can scan any resource that you have present in your deployment pipeline. There are other examples, lots of other examples here in this repository, in this Trivy demo repository that's also linked at the end of the presentation that you hopefully we'll have access to later on. But basically, and you can check that out. But what I wanted to show is, like, once you deploy all of your resources, you can also deploy for example, an operator, and Kubescape has an operator for their security scans, and also Trivy comes with a Trivy operator. You might have heard of Starboard or Kubebench. Who is here heard of Kubebench? A few people. Kubebench does compliance scanning. Now, we've integrated compliance scanning also in the Trivy operator. So the Trivy operator does vulnerability scanning of your running container images, of any configurations that you have running within your cluster, and also does compliance checks of your infrastructure. We also added, or we are about to add, actually, I think I can say that because it's public on GitHub. We're adding K-bombs, which is basically Kubernetes bill of material, to Trivy and the Trivy operator. So what does that mean? If you have heard of S-bombs provide you, for example, with an inventory list of all the resources that go into your container image. A K-bomb can check all of the different resources that are used within the Kubernetes native resources that you have basically within your kube system that run Kubernetes. So it can give you an inventory list of that. So we have, like, this is all the different things that the Trivy operator comes with. And then basically, once you install the Trivy operator within your cluster, it will perform the scans automatically. Now I have here the vulnerability reports of the different container images that have been scanned. Now I'm using here K9S to view them. And I see an overview of the different types of vulnerability I have present here. What you can do then is, for example, use the metrics that are provided by the Trivy operator and forward them to Prometheus to filter them, to create dashboards. I will talk a bit more about that later in my talk on how you can create dashboards. But these are the different things that you can do. How do I go back to my... I don't know how to go back to my presentation. Here. Okay, cool. This was the live demo. Cool. Then you can also make the scans more meaningful and, for example, use your existing tooling. If you're using GitHub Actions, Trivy, as well as other tools, they integrate with, for example, the security tab on GitHub, so you can also view misconfiguration issues and other security issues if you export them through your GitHub Actions to the security tab right there. Now, generally, you want to try to implement security tooling across your DevOps workflow. And that ultimately makes it easier to spot security issues and then kind of counteract anything that could go wrong in the long term. Now, this is my talk. If you want to see any other of my resources, I guess, and what I'm working on, I have a YouTube channel where I sometimes post end-to-end tutorials. So let me know if you want to see any specific tutorials that you're curious about. We also have an Aqua open source YouTube channel where you can see like specific Aqua tutorials of the open source tools, and then also have a weekly DevOps newsletter where she shares content. And here are some of the additional resources that I mentioned throughout this talk. Yeah, that's it. Thank you. Are there any questions about the things I shared? About Trivy. Now, who here has put their hands up of knowing Trivy but doesn't use Trivy? I'm curious if somebody wants to share. No? Any questions about somebody here? No? Oh.
I mean, I know Trivy and I want to use it, but my cluster is not finished, so I haven't implemented it yet. But
So
I
it's
will
like a
use
step.
it. Yes, I will use it.
Nice.
Coming soon.
Coming soon. Awesome. Anybody has any questions? Any feedback? You're free to share feedback or thoughts on what I shared. Maybe something you disagree with. No? No? Okay. We are all in agreement. You can also find me afterwards. Yeah. I'm going to be around until my next talk, I guess. Thank you.
Thank you very much.